Hello, for today's video lecture, we're going to be looking at centroids of area via composite parts. So, last section we talked about the centroid of an area and the centroid of a volume, etc. So the centroid of shape can always be found via integration like we did in that previous section. However, performing calculations by hand for more complex shapes can become unmanageably difficult. So if I give you the shape over here, it's not that complex a shape, but you can imagine trying to find the x and y coordinate of the centroid via integration is going to take a lot of work and a lot of calculus. So because of that, we do have alternate methods that we've developed to find these centroid locations since they are important. So one solution is to use the method of composite parts, which is what we're going to be talking about here today. We're going to take advantage of someone else's previous work. So someone else did the kind of calculus for a general semicircle, etc. And we're going to use all of that previous work to kind of stitch together a more complicated version of the centroid equation, skipping a lot of the calculus. Another method is software tools such as CAD software, SolidWorks, Autodesk Inventor. A lot of these can calculate these values for you. We're actually not going to be talking about this in the textbook. That's going to be more tool specific, but a lot of software tools do have ability to calculate centroids in both 2D and 3D shapes. So moving on, the method of composite parts, which is our focus today, works by breaking down complex shapes into simple parts. And so that's the composite parts namesake that we have here. We're going to be looking up the centroid information for each of those parts in a table. So the values in the table were calculated via integration, leaving things like width, height as general variables. Therefore, we can plug in any value for width or height and just find kind of shortcut through a lot of the calculus. So for each simple shape, we're going to need to determine three things when we look this up in the table. We're going to need to know the area of our shape. So how much is the area of this piece? What is the centroid location in the x coordinate, and what is the centroid location in the y coordinate? So if we have those three things, that's what we're going to be gathering from our tables. So the centroid tables, that is provided in this tool. If you're looking on the main or any of the pages, you should see it as one of those pieces on the right. For this part of the book, we're going to be working with the 2D centroid tables because we're looking at centroids of areas. So let's use a figure from the table to determine the location of a triangle's centroid. So here is a problem that we did before. We could do this via integration. It's really not that bad. If we look in our centroid table, we're going to see the following. So this is from the table in this book here. And we can see that the centroid, it is b over 3 and h over 3. So whatever the height is, take that over 3 and I go up that amount. Whatever the base is, I take that over 3, go over that amount. And this c is my centroid in the table. So here, I do need to do a little bit of reorienting, so not everything's going to exactly match. But if I do the height, so h is 4 inches, so my centroid location is going to be 4 over 3 inches up. For the b over 3, it'd be 6 inches is the base, so 6 over 3 is 2 inches. But it's not 2 inches over this way, it is 2 inches reflected, so it's from the kind of right angle side of the triangle. So it's going to be 4 inches out this way, 2 inches in from the right triangle. So make sure to reorient the tables, or reorient your shapes so that they're going to match the tables, essentially. All right, so using the method composite parts, what do we need to do to go through the whole process now that we discussed kind of some of the pieces here? So to use the method of composite parts, we first need to identify an origin point that we're going to use. It's going to be important to have everything from that same origin point. And we're going to break the shape down into simple parts. Each simple part you create must be in your centroid table. So that's going to be the limiting factor here. Regular areas, so if I'm adding material, essentially I'm going to count that as a positive area, and I can deal with holes or cutouts as negative areas. It is important to look around, see what you can do to take advantage of the negative areas as well. So this shape here, I can see it's kind of like a complex shape. It'd be complicated to do this, but it is essentially built of 3 pieces. So we go through the process. Step 1, add an origin point. We are going to need that for later analysis. And step 2 is going to be break this into pieces. So what I see is shape number 1, I see a semicircle. Shape number 2, I see this big kind of rectangle or square shape. And then I've cut off a corner. I counted that as a negative triangle there. So got my origin point, broken it down into pieces. I can move on to the next step for method of composite parts. So next up, we're going to record the area, X centroid coordinate, and the Y centroid coordinate in a table. So I really like using tables for this. It keeps everything organized. There's going to be a lot of information we need to kind of keep track of. So for this, the table for this one will look kind of like the following. So each row is going to be a different shape. So shape 1, shape 2, shape 3, I've got a kind of row for each one of those. And then the area, so area of a semicircle, you can look that up in the table. Area of the rectangle, and then the area, this will be a negative number down here for the triangular cutout. So area of each of the 3 shapes, and then I need to find the X and Y coordinates for the centroid. So we do need to remember to take the orientation and position of each shape into account when finding the centroid of the shapes, and this should be all relative to the same point. So remember, everything needs to be relative to this coordinate system that I put in early on. So let's talk about some of these pieces. So X bar and Y bar for some of these shapes. So first one is the semicircle. So this is the value in the table that I have, and this is what my semicircle actually looks like over here. And so this needs to get kind of rotated by about 90 degrees to make this work. So the centroid, this point C right here, is going to be 4 over 3 pi times the radius. So whatever the radius of this circle is, I need to go 4 over 3 pi back from the flat side. So the number I get out of this is not the number of the X bar. The number I get out of this, essentially, so I need to move over, essentially by 1 radius, and I need to go back by this amount. That would be my X bar that's going to go into the table I have here. Y bar, it kind of lines up with this axis here. We can also see that X and Y switch because I rotate my shape. So for Y bar, essentially the centroid of the circle is going to be somewhere along the x-axis, and so Y bar is going to end up being 0 in my table. All right, so that's shape number 1. Shape number 2, we're going to look at this briefly. So we've got a rectangle here. This one I don't really need to reorient anything, but I do need to take into account the position of the rectangle itself. So height over 2 and base over 2, the center of a rectangle is just half of the height, half of the base. Makes sense there. But I need to also take into account, so it's not just half of the base. I need to go all the way through the semicircle, then halfway through the base. So whatever the coordinate of the center of this rectangle is, that's going to be the X bar value that we're going to put into that table. All right, so now once we have everything into our tables, I've got area, X bar, and Y bar for each of the shapes. The coordinate for the centroid of each of these is given by the following formulas. So these look kind of complicated, but really this is just a weighted average. This is a weighted average by the area. So to find X bar for the total composite shape, I'd do area 1 times X bar 1 plus area 2 times X bar 2 plus area 3 times X bar 3. Take that number and divide it by the total area. So area 1 plus area 2 plus area 3 for that piece. So table makes it easy because you're doing this times this, this times this, this times this, divide by total area. Y bar is going to be the same, more or less the same process except with the Y bar values. So area 1 times Y bar 1 plus area 2 times Y bar 2 plus area 3 times Y bar 3, divide by the same area. So same denominator in both of these. I'm going to divide by the total area for both of these. So once you have each of those, you get a coordinate for X bar and Y bar. That represents the point in space relative to the axes that you've identified. That is the centroid of your given shape. All right, so that's all we got for today's video lecture. Thank you for watching, and I hope to see you again.